Welcome to the 2020 GCE A Level H2 Chemistry MCQ Solutions, brought to you by TSA The Science Academy. We're going to take a look at the course of 30 MCQs in this paper, thinking through the methods as well as steps that we should undertake to approach each of the questions, and what are some of the pitfalls and what are some of the clues that the question could have given to us to more accurately select the correct answers. Let's start off with MCQ 1. In MCQ 1, we are given that the shape of each of your p orbitals can be represented as two lobes. Now, again, just drawing out the axis itself, we will see that for our p orbitals, we have the following sublevels: the px, the py, as well as the pz. So again, just expressing this on an axis of x, y, as well as z. For the case of the px sublevel, we're going to have a dumbbell shaped structure here. Now this is represented as two lobes. We can take this as one lobe and we can take this as another lobe. Now again, for the case for the py, just as a representation, you can draw this on the axis itself. This is also again to be seen as two lobes. And lastly, for the case of my pz, representing it in yellow color, we're going to have this as two lobes as well. So the complexity of this question here is, again, if we're going to refer this with respect to the 3D orbitals, how many of such actually has the p shape that's found within there? So I think a little bit of a memorization of how the 3D orbitals look like. We have a total of 5 sublevels. We have the 3D xy, the 3D xz, the 3D yz, 3D x2 minus y2, as well as 3D z2. Now, in this case here, drawing each of them, so long that there is one p orbital that's two lobes, so we're looking for 4 lobes. So each of them must have at least 2 p orbitals that's found within that. Alright, so for first case of 3D xy, so again using the same axis of x, y, and z for the rest of this drawing, we're going to have the case of x, y, z. So we're going to have one on z itself. We're going to have one that's between y as well as z. So over here we have a total of 4 lobes. So looking at the case of 3D xz, I'm going to have it over at the y, and in between the case of my x as well as my z. This also represents a total of 4 lobes. 3D yz. So this is going to be on the x, and between the z and y, representing a total of 4 lobes. 3D x2 minus y2. We're going to have it on the x-axis as well as on the y-axis. This also gives us a total of 4 lobes. And for the case of 3D z2, we're going to have 2 lobes on the z-axis, but a circular structure that is found on the x as well as the y-axis. So this gives us only a total of 2 lobes. So doing the counting over here, we have a total of 4 sublevels of the 3D orbitals that give us 4 lobes. The answer for 1 is C.